Hey guys, how's it going? Welcome to the next video. I had a couple people ask me about micropiles and how they compare to peering systems and things like that. So I wanted to go ahead and address them first. First, I'm going to talk about micropiles, what they are, what some of their benefits are and stuff like that, and then make a different video about how those kind of compare to push piers, helical piers, or steel underpinning systems and things like that. So what is a micropile? We had a video about caissons where you've got footing of a structure, and then you've got sill plate in the wall. And what a micropile or a caisson, both are basically interchangeable. They're the same thing, but a micropile is a smaller caisson, right? It's a smaller pile system than what a caisson would be. So you've got your footing underneath, they'd excavate down to expose the footing underneath, and then generally they'll build a grade beam out, and in that grade beam they'll connect micropiles here. Generally that's how they do it. They don't really use micropiles as like a retrofit under an existing, because you want to strengthen the footing and make it a little bit beefier, and trying to get the concrete at the right angle to get underneath the structure is actually really, really difficult. So most often you'll see like a grade beam poured with a micropile system, and what that means is go ahead and excavate this out to expose the bottom, right? And then they'll drill down, and they have a lot of different drilling techniques in order to get down. Oftentimes you see they'll like drill down and put like a casing down into the ground so they can just stop any soil from sloughing into the hole, stop any collapse. It helps you get through like cobbles and different stuff like that. And the big thing about like drilling and this type of systems, it allows you to get to a target depth based off of a geotechnical report, and kind of guarantees that you can penetrate through that weak layer of soil, which I'll try to illustrate in a moment, and make sure you get deep enough to transfer the loads into competent strata, right? So they will excavate all this, drill down, whether they put the casing inside, which is just like a steel tube that goes down and it stays in the ground. They don't remove it, right? Now you can pull the casing out, that's fine. It just creates, again, kind of a lot of like sloughing in from the soil at depth. If you got like a super weak layer of soil here, that could cave into here and fill up your hole. Or if you've got like, cobble soils, or cobbles in the soil, sorry, and then they drill down and some of these rocks will fall in and again plug the hole. The biggest thing obviously being you don't want to plug the hole. And the reason why you don't want to do that is because after they've got this whole thing drilled out, right, casing or no casing, then they'll take a rebar cage, which generally this system is designed by an engineer, size, thickness of rebar, all that fun stuff, spacing of the rebar, whatever goes in, but all of this reinforcing steel goes in, and then they will go back and fill the entire thing up with a high strength cementitious grout that kind of ties this rebar cage system into the adjacent soils through and through, right? And then it creates an overall structure here that's essentially like a deepened foundation system. It's very, very strong. It's I don't have any real complaints against something like this. It's a good repair system. And then again, after they're done, I'm green, they'll put the rebar system here, they'll dowel it in, so they tie everything together, and then they'll come back and they'll pour the concrete up at the top to kind of tie all of that. So all of this system becomes one singular structure. It's a bigger, beefier footing. It's basically like doing the grade beam or extended footing system, but is addressing the soils issue. You wouldn't really want to, if you have settlement or heave, I mentioned in a different video, you don't really want to just do like an extended footing or a deepened footing, because if you don't solve the soil issue, you're just adding a ton of weight and you're not actually fixing the soil problem, and that generally creates a catastrophic failure in the future, right? So that's kind of what it looks like on the vertical plane, or from a profile view. And what that looks like if I have the corner of a house that's settled, right? Neat. and you know, it's down here, it's down here. Essentially, they'll take these micropiles and they'll put them, struggling, they'll put them, you know, they can put these on corners here, but offset, right? So they'll put one here, 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 and then they'll tie all of it together with a grade beam, right? And these could be, you know, they could be like 5 foot on center, 6 foot on center, 8 foot on center if you're stabilizing or something like that. And the biggest difference, if you, I mean, remember I drew something like this when talking about grade beams also. Grade beams are generally, standard piles are generally just bigger, right? Micropiles are generally between 5 and 12 inches in diameter versus like a grade beam, which can be 4, 5, 6 feet in diameter. Some of the advantages to using this system, very little vibration. Like when you do the push piers, remember you're like picking up and shaking the house because you're using the house in order to do that. You're not really doing any compaction. You're not doing anything that vibrates the soil except for drilling down and pulling that soil out, right? So very little vibration involved with the installation of this. These things can get up to, I think it's 200 tons or upwards of 200 tons. So they're really, really good for large structures, carrying a whole bunch of weight. They're great for compression loads, tension loads, and lateral loads, which is why this is very popular in the county of Los Angeles, which, you know, doesn't allow helical piles to be used for any sort of like lateral loading or anything like that. So you can turn over to like a micropile system in order to do that. One of the tough things about micropiles is when you've got a structure, right? I'm going to go kind of another type of angle here. I've got my house, right? And then I've got my footing. What's really, and then I'm gonna do the side view too, okay? Just because, right? It's a boot. Anyway, when you get something like this, the hardest part about that, you're gonna sink these micropiles, you know, again, every 5 or, geez, I'm having a hard time with these pens. You know, you're gonna sink these every 5 or 6 feet or whatever. And then you've got, what, bedrock down here. Probably should change the color. We'll call this our weak soil zone, right? But competent soil down there. And then especially if you have like a slope and your slip plane. So you have to start, and again, I know I say this, I've said this in every video, start with an engineering report. Get the geotechnical investigation done. You can try to do things without a geotech investigation. There is general rules that you can follow in order to execute a project like this, and you're probably pretty safe doing that. But if you want to know that you've solved the problem and stick a 25-year warranty on the things that you're doing, get the geotech report. You have to. You got to know how deep you're going to go. You got to know about lateral loading and hillsides and slopes and stability and blah, 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 blah. There's so much involved in order to do something like this. And we'll get into that more when I talk about like push piers versus a micropile system, but that'll be for the future. So they design these things to go down in a bedrock, and just like always, I'm just going to change the color here. And like always with caissons, micropiles, whatever, you want to go to bedrock and then about, 4 to 5 feet at least into bedrock or competent strata. So these things will go all the way down here. Your geotech report will let you know if there's going to be any sloughing or any chance of the soil collapsing into the holes that you drill. So that'll determine your drilling, not pattern, but method, the drilling method that you utilize in order to do this. And then as far as lateral loading, you might have to make these things a bit thicker, right, in order to resist the slope creep or any sideways loads that are put on this. The problem with using micropiles in a retrofit application is that you could try to put like maybe like a temporary jack here and try to pick it up and try to lift this structure back to level, but those would have to be sacrificial first. Second of all, they get in the way when you're trying to put your grade beam in. You're trying to, remember, dowel into your existing footing and you'd be excavating that, and you got to get concrete to pour inside there, and you cover up that temporary jack. The second problem is that these jacks however often you put them on there in order to try to achieve this lift, have a really, really tough time because they've got the tiny little, tops. That creates a point load that has a tendency to crack the footing. You can try to spread that load out like they do with concentric piers in order to put like a steel bar or something across in order to span that out and make it more like a spread load instead of a point load while you're pushing up on that. That might help. Just one way or the other, it makes it very, very difficult to try and lift this up. Finally, even if you put a base down at the bottom of these jacks, I'm still using green, geez. Even if you put a base at the bottom of these jacks, right here, let's say, you can do like the carbon fiber pads or concrete or whatever. You can try to put a base down there, but most often if the soil directly below the footing, which is, resulting in the settlement of the structure, is too weak, then as you push up against this, it'll actually push your jack down instead of trying to lift the footing up, right? So that's part of the only real pitfall for micropiles, really. As far as cost, they're generally kind of cost comparative. They're a little more expensive, but not much than your steel underpinning systems. Mainly because you're gonna have to come back and pour this grade beam across the entire section of the footing. So there's a lot more labor involved anyway, I'm getting into something I shouldn't be. But cost comparatively, they're generally close to the same price. I've seen between $120 to $150 per foot in order to do a micropile. And then you have to bear in mind, however deep this is, we'll call it 20 feet deep in order to hit your bedrock. You're 5 feet, so that's 25 feet per pile, 25, 50, 75, 100. And then you have the span of the structure as far as length in order to get that as well. So there's a lot of engineering and a lot of stuff that has to go into designing your micropiles. You have to take that step. This is not one of those ones that you can just kind of willy-nilly and do it. They need to specify the type of concrete, the rebar patterns, how far you need to space these things apart, how deep they need to go, etc. Soils engineering, structural engineering on this, step one. Step two is the execution of all of that. And overall, you have a pretty good system. Big question for you is the ability to lift as a retrofit application when you have subsidence or any settlement of a structure, and high pressure concrete that also has to be designed for the backfill. Yeah, that's it. These are really, really good, again, for high loads. They're great for subsidence as far as stabilization is concerned. These are used a lot in seismic retrofits to increase the seismic resilience of a structure. And again, these are just like the caisson systems, just much, much smaller. So this is just an introduction to micropiles, how the means and methods and stuff is kind of done on that. I'm going to make another video in a couple weeks and kind of compare how this looks to your steel underpinning systems, which is your push piers, your helical piers, and your concentric piers. Please click like, subscribe, and all the stuff, and thank you guys for your attention.